Hi class, this is course 3, lesson 59 on experimental probability. We've been talking about theoretical probability, which is where we analyze a situation, or we say in theory that's how it would work, flipping coins and rolling a number cube. That's what we've been dealing with. We don't actually flip the coin 100 times, we use the theoretical probability. Experimental probability is where we analyze the statistics of an event. So we actually perform trials. And get some data, some statistics to analyze. So experimental probability is the number of times an event occurs over the number of trials that you've performed. It's used widely in sports, an 80% free throw shooter, batting averages. So we're familiar with experimental probability even if we don't realize that we are. So a softball, we're going to do 3 problems. A softball player has 21 hits in 60 at-bats. Express the probability the player will get a hit in her next at-bat as a decimal number with 3 decimal places. Okay, so probability based on trials is the number of what we want, hits, 21, out of the number of attempts, and it's 60. Now don't get tricked up into thinking that we need to add a next at-bat. That's not what we want. We only want the probability that has been established up to this point. Okay, so this is the number of hits out of attempts. And we need to express it as a decimal number with 3 decimal places. So we need to divide, let's see, 3, 0, 3, add a 0, 0, this would be a 5. Okay, so now don't make this mistake and just circle that answer because you want 3 decimal places, so you have to add a 0 here. That's your decimal number probability. When you get batting statistics, they're usually expressed with 3 decimal numbers. Okay, a salesperson distributed free samples at the mall. 50 shoppers accepted the samples and 30 did not. What is the probability that a shopper at the mall will accept the salesperson's samples? So remember, it's the favorable outcomes, so we want that they will accept. So how many accepted? Accept over attempts or trials, or in this case customers. So we have how many accepted? 50 shoppers accepted out of how many? Well, 50 did and 30 did not, so this would be out of 80. So what is the probability that a shopper at the mall will accept a salesperson's samples? You can just leave this as 5 out of 8. That's a probability. It's a fraction. That's perfectly acceptable. Now answer this question. If 400 customers are expected on the next shift, how many samples should be ready? Well, 5 out of every 8 will take a sample, and if we're expecting 400, then how many samples do we need? So this would be times 50. So times 50. So we should have 250 samples ready to go. Okay, so not only are statistics or experimental probability used in sports, they're used in business as well. Okay, now here's an example, or here's a situation where we use models. So we can simulate experiments using models such as spinners, number cubes, coins and marbles. Not every experiment makes sense to do, so we have to use simulations. And here's an example of one that wouldn't be so successful. So a commuter plane arrives on schedule 2/3 of the time on any given weekday. And now Heather's wondering what the probability is that it will arrive on schedule on a Tuesday, Wednesday, and Thursday in the same week. So not just on any given weekday, she wants these 3 in a row. So how could the experimental probability be found, and why is this impractical? So if you wanted to perform this as an experiment, you would have to record the Tuesday, Wednesday, Thursday flight data for many weeks. Okay, now is that reasonable? I mean, you could do that, but she just wants to know this information. Businesses may use their actual data to determine these scenarios over time, but if it's an experiment, if I asked you to do this, would you actually have time to record the Tuesday, Wednesday, Thursday data? No. It would take too long. That's why it's impractical. So B, how can you use the spinner at the right to simulate the experiment? So notice we were told that the flight's going to arrive on schedule 2/3 of the time. And so we took a spinner and divided it into thirds and then put 2 of those thirds as on schedule and 1 as not on schedule. So how can you use that spinner to simulate the experiment? Well, you're going to perform 3 spins in a row. That would simulate Tuesday, Wednesday, Thursday. And you're going to record that data. Okay, so that would tell you, did they all arrive on schedule? And then you would keep track of the number of 3 on schedule, the Tuesday, Wednesday, Thursday, and divide that by the number of weeks attempted. Okay, so each 3 spins is 1 week. So you'd spin it 3 times and either get a yes or a no. Okay, yes, they're all on schedule, or no, they're not. And then that would be divided by 1. And then you would come up with 3 more spins and get a yes or a no. So now you'd have 2 yeses divided by 2. Okay, does that make sense? I hope it does. So you're gathering information and keeping track. So you could spin the spinner 300 times and keep track, and that would be the same as 100 weeks of flights. Okay, so there are a lot of different situations where we use models, spinners, numbered cubes, coins, and marbles, to simulate those actual events. Okay, so this is just a different way of looking at probability. Instead of using just analyzing a situation, we're going to actually use data and actual attempts or trials to get the probability. So as you work on the assignment, let me know if you need some assistance. Otherwise, I will see you in class.